Something entered our solar system, and it never left. Not a comet that swung by and vanished. Not a rock that grazed us and moved on into the dark. Something that came in from between the stars, crossed the threshold, and stayed. And here is the part that should stop you cold. If that has happened even once, then the sky above your head is not what you were told it was. Sit with that for a moment. You were raised on a picture of the solar system as a sealed room, 8 planets, a sun in the middle, a tidy little machine spinning in the black, closed off from everything else. The stars were far away and stayed far away. Whatever happened out there, happened out there. It did not come here. That is the picture almost everyone carries. Neat, comfortable, and wrong. Because the room was never sealed. The doors were never locked. And things have been drifting in through them for as long as there has been a solar system to drift into. We just could not see them until recently. That is the gap I want to walk you through today. The gap between the sky you believe in and the sky that is actually there. It is a wide gap, wider than almost anyone suspects. And once you see how wide it is, you cannot unsee it. Here is what I love about this. You do not need a telescope to follow it. You do not need a degree. You just need to be willing to reason one careful step at a time from your armchair. And if you do that with me all the way to the end, you will never look up at the night sky the same way again. I promise you that. Not because I am going to tell you something to believe, because I am going to hand you the steps and you are going to build the conclusion yourself. That is the difference between being told and knowing. One you carry loosely, the other you own. Let me start somewhere strange. Not with the object, with the question of how anyone could possibly know anything at all. Before we chase what entered our solar system, we have to be honest about a harder problem. How do we know anything about the sky in the first place? You cannot go there. Nobody has flown out past the planets and come back with photographs. The furthest any human being has ever traveled is the moon, a stone's throw in cosmic terms, close enough that the light from it reaches you in barely more than a second. Everything beyond that, everything, you believe because of light. Light that left something far away, traveled across an unimaginable distance, and landed in a lens. That is the entire game. That is all we have ever had. A stream of tired old light arriving from the deep. And light is slow. I know how that sounds. Light is the fastest thing there is. Nothing beats it. It is the speed limit of the whole universe. The one number nothing can exceed. But the distances are so vast that even light crawls. This is where a single idea becomes the key to everything. The light year, not a measure of time, despite the name, a measure of distance. The distance light covers in 1 year, and light covers in 1 second enough ground to circle the Earth 7 times. Let that settle. 7 laps of the planet in the time it takes you to say the word. Now let it run for a whole year without stopping. That distance is a light year. Try to feel the size of that. In a single second, light could go around your whole world 7 times over. In a single minute, it clears the gap between the sun and the Earth, and then some. In a single hour, it crosses a distance that would take a fast car millions of years to cover. And the nearest star beyond our own sun is more than 4 light years away. 4 years of that impossible sprint, without pausing, without slowing, just to reach the closest neighbor. Send a message today at the speed of light, and the answer, if anyone were there to send one, could not return for more than 8 years. That is the true scale of the neighborhood. Not miles, not thousands of miles, years of light. So when you look at a star, you are not seeing it. You are seeing the light it sent out. If that star is 100 light years away, you are seeing light that left it 100 years ago. You are looking at the past, always. There is no way to see the sky as it is right now. There is only the sky as it was. The further out you look, the deeper into history you fall. This is not a trick or a poem. It is just the plain arithmetic of a slow signal crossing a huge room, which means the whole night sky is a kind of memory. a layered photograph of different moments, all arriving at once. The nearby stars are recent, the distant ones are ancient. Some of what you see may not even exist anymore. It burned out long ago. And the news simply has not reached you yet. You are watching ghosts, beautiful, precise, measurable ghosts. When you glance up at a scattering of stars, you are not looking at one moment. You are looking at 100 different moments stitched together on the same black cloth. Some of that light is younger than you. Some of it is older than the human species. And you take it all in with a single glance, never noticing that you are reading a history book with every page torn out and reshuffled. Now push that further, because this is where it gets almost unbelievable. There is a wall out there, not a physical wall, a wall in what can be known. Look far enough into space, and you look far enough into the past, and eventually you reach the moment when the universe first became transparent. Before that, it was too hot and too dense for light to travel at all. The whole cosmos was a fog. Photons could not get anywhere. They bounced and scattered and went nowhere. And that oldest light, released when the fog finally cleared, is still arriving. We can detect it, faint, cold, coming from every direction at once. The cosmic microwave background, we call it, the afterglow of the beginning. And it is a hard limit. You cannot see past it, not because our instruments are weak, but because there is no earlier light to catch. The fog blocks it, so the observable universe has an edge, and the edge is made of time, not distance. Everything we will ever know sits inside that boundary. This matters more than it seems. It means our knowledge is bounded, and we know exactly where the boundary is. That is not a weakness. That is the most honest thing science ever did. It drew a line and said, out here we can see, past this line we cannot, and here is precisely why. Think about how rare that honesty is. Most stories about the world claim to explain everything. They have an answer for every question, and no edges anywhere. But a real understanding of the cosmos comes with its own map of where it stops. It says, here is what the light can tell me, and here is where the light runs out, and past that point, I will not pretend. That refusal to pretend is the engine of the whole thing. It is why any of it can be trusted at all. An explanation that cannot fail can never really succeed either. It is the ones that risk being wrong that are worth listening to. So keep this in your pocket for the whole journey. Everything we claim about the cosmos, we earn through light, through distance, and through time, which turn out to be the same currency spent 3 different ways. And every good claim comes with a boundary attached. A theory is only worth as much as the observation that could prove it wrong. That is the word to hold on to, falsifiable. A real idea sticks its neck out. It says, if you see this, I am dead. A fake idea explains everything and risks nothing. Keep that test in your hand. It will do more work in the next hour than any fact I could give you. Every time I make a claim, ask yourself quietly, what would have to be true for this to be false? If nothing could ever prove it wrong, be suspicious. If something could, and it has not, then you are standing on solid ground. There is one more tool we need before we begin. The most humbling idea in all of science, and the most powerful, the Copernican principle. It says something almost embarrassing in its simplicity. You are not special. Your position is not privileged. When we thought the earth sat at the center of everything, we were wrong. When we thought the sun was the center, we were wrong again. When we thought our galaxy was the whole of creation, wrong once more. Every single time humans placed themselves at the middle of the map turned out bigger and stranger, and we turned out to be sitting off in some ordinary corner of it. So the safest bet, again and again, is to assume you are typical, not the exception, the rule. This is sometimes called the mediocrity assumption, and I know that sounds like an insult. It is not. It is a lantern, because if your corner of the universe is ordinary, then whatever is true here is probably true nearly everywhere. And that lets you reason about places you can never visit. It lets you fill the whole dark room by studying the one small patch you can touch. You cannot go to the next star, but you can assume it plays by the same rules as this one, and that single assumption unlocks the entire galaxy. It is the closest thing we have to a key that opens every door at once. Hold those three tools now, light as the only messenger, the boundary of what can be known, and the assumption that you are not the center of anything. With just those, we can begin to ask what came into our solar system and refuse to leave. Everything from here forward is built on those three. So if any of them felt shaky, go back and let it settle. We are going to lean on all three hard. Here is the first thing worth sitting with, and it is stranger than any spaceship. Picture the solar system honestly for a second, not the poster on the classroom wall, the real thing. The sun, the planets, and then, far out past the last planet, a vast cold reservoir of frozen debris. Chunks of ice and rock left over from when everything formed. We call that outer ring, the Kuiper belt. And beyond even that, a faint scattered halo of icy bodies stretching out ludicrously far toward the nearest stars. That is the true shape of our home. Not a tidy machine, a sprawling, ragged cloud with a bright bulb in the middle. And that outer halo is enormous. It does not stop just past the last planet. It reaches out a good fraction of the way to the next star. Think about what that really means. The planets you learned as a child, all 8 of them, huddle in close around the sun like moths around a lamp. But the debris does not. It sprawls out into the dark thousands of times further than the outermost planet, so far that a body sitting at the edge of it takes not years, but many thousands of years to circle the sun once. Trillions of frozen bodies, loosely held, barely tethered by the faint far reach of the sun's gravity out at that distance. The sun's grip, so firm on the planets close in, grows feeble and thin out at the edge. A body sitting way out there is held by the lightest of leashes, and a light leash is easy to break. Now ask a simple question. If our solar system is a ragged cloud of loose debris, and it is, then what about the star next door? By the Copernican principle, it should be much the same. A ragged cloud of its own, and the star after that, and the star after that, every star, most likely, wrapped in its own halo of leftover rubble. There's no reason to think our star is the one special star with a debris cloud and all the others are clean. That would be exactly the kind of self-flattering exception the Copernican principle warns us against. Remember the test. What would have to be true for our star to be the only one with leftovers? You would have to believe that the same process that built us out of a cloud somehow built every other star out of nothing but tidy emptiness. That is not humble. That is not likely. That is a fairy tale about our own importance. Here is the turn. Stars are not fixed. They drift. The whole galaxy is turning a slow, majestic wheel, and the stars swing around it at different speeds on different paths. They pass each other slowly over millions of years, but they pass. Some approach closer than others, and when a star drifts by, its gravity gives the loose rubble at the edge of its cloud a gentle tug. Some of that rubble gets flung loose, kicked out entirely, set free to wander the galaxy on its own, belonging to no star at all. That light leash I mentioned, snapped by a passing pull. And it does not even take a close encounter. Remember how thin the sun's grip is out at the edge. A body way out there is already balanced on a knife. The faintest outside nudge can tip it over. A passing star that never comes anywhere near the planets can still reach across the dark and stir the outer halo. So every star, over its long life, is quietly shedding pieces of itself into the dark. Not once, constantly. A slow leak that never stops from every star that has ever formed. And there are hundreds of billions of stars in our galaxy alone, each one leaking, each one for billions of years. Follow that reasoning, and something inevitable falls out of it. If every star sheds debris, and stars have been doing this for billions of years, then the space between the stars is not empty. It is littered. salted with countless orphaned rocks and shards of ice, each one thrown from some distant system long ago, drifting alone in the dark, an interstellar object, a piece of another world's leftovers, cut loose and roaming, not one or two of them, an ocean of them, a galaxy full of message bottles, each carrying a piece of a shore we will never visit. You did not need a telescope to reach that. You reached it by reasoning. Our system leaks debris, so every system leaks debris, so the galaxy must be full of the stuff. It almost has to be true. The only way it could be false is if our solar system were somehow unique, and the whole thrust of everything we have learned says it is not. Tested against the falsifiable rule. What would have to be true for this conclusion to be wrong? Either our sun would have to be the one star with a debris cloud, or stars would have to never drift past each other, or gravity would have to work differently at the edges of systems. None of those hold. Not one. So the conclusion stands, resting on nothing but plain steps you could check yourself. Now the killer question. If interstellar space is full of these wanderers, how many drift through our neighborhood? And the answer, once you run the arithmetic, is astonishing. Our solar system is not a small target when you account for the sun's gravity, which reaches out and bends the path of anything passing near. The sun does not just sit there. It pulls. It reaches out and grabs at whatever comes close, funneling passing bodies inward, widening the net far beyond the size of the planets alone. Space is enormous, yes, but the wanderers are enormous in number. And time is enormous in supply. Multiply a huge sky by billions of years. And rare events stop being rare. They become routine. Let me make that multiplication real for you, because it is the heart of it. Imagine the space around us is nearly empty, so empty that in any given small patch, on any given day, the odds of a wanderer passing through are tiny, almost nothing. But now widen the patch to the whole vast reach of the sun's gravity. And widen the time from one day to billions of years, a vanishingly small chance multiplied by an unimaginably large volume, multiplied by an unimaginably long stretch of time, does not stay small. It grows into a steady stream. That is how you turn nearly never into all the time. Order of magnitude by order of magnitude, the arithmetic drags a rare event into the realm of the routine. Here is a way to feel it in your own life. Any single raindrop landing on any single blade of grass is a near impossible coincidence. One drop out of billions falling on one blade out of billions. And yet in a rainstorm, every blade gets wet, not by miracle, by sheer multiplication. Enough drops, enough grass, enough time, and the impossible becomes the ordinary. The galaxy is the storm. The wanderers are the drops. And our little patch of ground gets wet more often than anyone imagined. The reasoning says these visitors should be passing through constantly, not once in the history of humanity, constantly. Right now, as you listen, pieces of other star systems are almost certainly drifting silently through the outer reaches of our own. We simply cannot see them. They are small, dark, and cold, and they do not shine. Our telescopes catch only the tiny handful that come close enough and bright enough to notice. For every one we spot, there are thousands we miss entirely, slipping through the dark without ever catching the sun. Think of a lighthouse beam sweeping a foggy sea. It shows you the one boat that happens to cross the light. It does not show you the fleet passing in the dark all around it. And for most of human history, we caught none. Not because they were not there, because we were not looking and could not have seen them if we tried. The technology to spot a dark rock the size of a building moving fast against a field of stars is very new. Think about what that task actually demands. You need a survey that photographs the whole sky over and over, night after night. You need machines to compare each new image against the last, hunting for the one faint dot that moved against the fixed background of stars. You need software patient enough to sift millions of specks and flag the single one that shifted since yesterday. And you need to do this fast enough to catch something that is only near enough to see for a few weeks before it is gone forever. That capability is only about a decade old. Only in the last decade or so have we been able to do it at all. Before that, a visitor could pass right through and leave no record because nobody had eyes quick enough or wide enough to notice. So the sky did not change. Our eyes did. We finally opened the door and looked, and there they were. Exactly as the reasoning predicted, visitors from other stars threading through our system on their way to somewhere else. The first one confirmed, a strange, elongated thing tumbling through on a path that could only have come from beyond. Then another, more clearly a comet, but again on a road no local body could travel. And the reasoning says these are just the beginning. The first 2 grains of sand from a beach we have only just started to sift. As the surveys grow sharper, the count will climb, and what feels like a rare marvel today will feel like weather tomorrow. Sit with what that does to the sealed room picture. The room was never sealed. It never could have been. The same physics that built our solar system out of a leftover cloud guarantees that every solar system leaks, and that the space between them is thick with the crumbs. Your night sky is not a closed machine spinning alone in the void. It is one house in a crowded neighborhood with things drifting between the houses all the time. That is not speculation. That is what the logic forces. And it is only the first thing. Here is another thing worth sitting with. And it turns the visitors from a curiosity into a genuine mystery. Most of the wanderers we would expect to see should behave. A rock is a rock. It comes in fast. The sun's gravity bends its path into a sharp curve, and it whips back out into the dark, never to return. That is orbital mechanics, the plain arithmetic of how gravity steers a moving body. You can predict the whole path from a few measurements: where it came in, how fast, at what angle. Gravity does the rest. The math is old, and it is reliable. It is the same math that guides a spacecraft to a distant world with the precision of a thread through a needle across years of travel, arriving within minutes of the predicted moment. It put footprints on the moon. It slings probes past one planet to steal a little speed and fling them toward the next, all worked out decades in advance. When it comes to gravity, we are not guessing. We are among the most confident we have ever been about anything. So when the first confirmed interstellar visitor appeared, the expectation was simple: track it, predict its path, watch it leave. And mostly that is what happened. It came in from an odd angle from outside the flat plane where the planets orbit, which was the first clue it did not belong to us. Everything in our system, the planets, most of the asteroids, tends to lie in roughly the same flat disk, like markings on a record. This thing plunged through from above, off the disk entirely, coming down at a steep angle no local body would take. It moved too fast to be one of ours, faster than the sun could ever have flung it, which meant it had arrived carrying speed from somewhere else. That extra speed is a signature you cannot fake. A body born here and thrown outward by the sun has a top speed, the sun's gravity sets, an escape velocity, a ceiling on how fast anything local can be moving as it leaves. This one was going faster than that ceiling, so it did not come from here. It could not have. The arithmetic ruled it out. Everything about its trajectory said stranger, said outsider, said this thing was born around another star and has been traveling for who knows how many millions of years to reach us. A shard of some other worlds, making a drift for ages, threading at last through ours. It had spent longer alone in the dark than our whole species has existed, and it passed through our patch of light in a matter of weeks before vanishing back into the black. And then, on its way out, it did something the arithmetic did not allow. As it swung away from the sun and out toward the dark again, it sped up, just slightly, but it sped up. It accelerated when gravity alone said it should have been slowing down. Think about what that means. A ball thrown upward slows as it climbs, pulled back by gravity, every second losing a little speed. This object, climbing away from the sun, should have been losing speed the same way, and by an amount you could predict to a fine precision. Instead, it gained a touch, a tiny, measurable extra push in a direction gravity could not explain. This is what we mean by non-gravitational acceleration. The body moved as if something other than gravity was nudging it along. And that word, nudging, is doing a lot of work because there was nothing visible doing the nudging. Now, before your imagination sprints off, let me hold you back, because this is exactly where reasoning has to be at its most careful. There is a boring explanation, and boring explanations deserve to go first, always. That is Occam's razor. When you have two explanations, prefer the one that needs fewer new assumptions. Do not invent a marvel when a mundane thing will do. This is not about being a killjoy, it is discipline. The most exciting sounding answer is usually the one propped up on the most unproven guesses, and every unproven guess is a place the whole story can collapse. A tower built of maybes falls at the first push. A short argument built of knowns tends to stand, and there is a mundane thing that will do: comets. A comet is a dirty snowball. When it gets near the sun, the ice on its surface warms and turns straight to gas, skipping the liquid stage entirely, and that gas jets off into space. That jet acts like a tiny engine, a gentle, uneven thrust. It can push a comet just slightly off the path gravity alone would carve. So a visitor that vents gas as it warms could speed up a little, exactly the way this one did. No mystery required, just ice, sunlight, and a small push. We see this happen with ordinary comets all the time. Their paths wander a hair off pure gravity, and venting gas is why. We have measured it on dozens of local comets. It is textbook, except here is the wrinkle that keeps the mystery alive. When a comet vents gas, you can usually see it. The gas glows. It forms a fuzzy halo, a tail, a visible cloud of released material streaming away from the sun. That is what a comet is to your eye, that bright smudge with a tail. And this visitor showed none of the usual signs you would expect from a body venting enough gas to shove itself off course. No obvious tail, no clear glowing cloud. So the boring explanation is possible, but it is not clean. It leaves a loose thread. The push was there. The visible cause of the push was not obvious. And in science, a loose thread is not a scandal, it is an invitation. Now, there are ways to save the boring story, and honesty demands we walk through them too. Maybe the venting gas was of a kind that does not glow brightly, so we missed it. Some gases stream off nearly invisible to the instruments we used. Maybe the object shed material in a form too faint or too fine to catch with the instruments we had in the short window we had them pointed at it. Maybe it vented from only one small patch, a single active spot on an otherwise dead surface, too little to build a visible tail, but just enough to give a nudge. Maybe we simply did not get a long enough look, catching it late and losing it fast. All of those are reasonable. All of them keep the mundane explanation alive. But notice that each one is a patch. Each one adds a small extra assumption to make the simple story fit. And when the simple story needs several patches to survive, it stops feeling quite so simple. Occam's razor cuts both ways. A boring explanation loaded with special exceptions is no longer the cheapest one on the table. This is the honest shape of the thing. We saw a body from another star. It moved in a way gravity alone does not permit. The most likely cause is venting ice, a perfectly natural process. But the evidence for that venting was thinner than we would like. So we are left holding a genuine bounded puzzle. We know exactly what we saw, we know exactly what we could not fully explain, and we know exactly what kind of observation would settle it. Catch the next one earlier, watch it longer. Look for the faint glow of gas we might have missed. Point better instruments at it while it is still close. The puzzle is not a dead end, it is a to-do list. And the second interstellar visitor, the clear comet that came later, behaved more tidily, venting visibly, which is a reminder that most of these objects probably will turn out ordinary. But the first one still sits there, not quite closed, waiting. That is the pattern I want you to notice, because it will come back. A visitor arrives from beyond, it behaves almost normally, and then it does one small thing that the simplest story struggles to cover. not a thing that proves anything wild, a thing that refuses to fully close. And a universe that keeps leaving small threads untied is far more interesting than one that hands you tidy answers. Because every untied thread is a place where what we believe and what is true have not yet been forced to meet. Every loose thread is a door still standing open, and a good mind does not slam that door in a hurry. It leaves it open and marks it and comes back with better tools. Here is a third thing worth sitting with, and it moves the whole question onto a bigger stage. Step back from the single rock, step way back, because the real question underneath all of this was never about one object. It was about whether we are alone. The wanderers matter because they force that question into the open. If pieces of other star systems can reach us, then the walls between the stars are thinner than we thought. And if the walls are thin for rocks, they are thin in principle for anything. Let me build this the honest way, with a tool made exactly for it. The Drake equation. Do not let the word equation scare you. It is not really about getting a number. It is a way of breaking one impossible question into smaller, answerable ones. It says, roughly, if you want to know how many civilizations might be out there able to send us a signal, you multiply a chain of fractions together. How many stars are there? How many have planets? How many of those planets could support life? How often life actually starts? How often it gets complex? How often it gets clever enough to build a signal? And how long such a thing lasts before it fades? The beauty of it is not the answer at the end. It is what it does to the question. It takes something that feels hopeless, are we alone, and it cuts it into pieces. You can chip away at one at a time. Some pieces we can now measure. Some we can only guess. But the ones we can measure, we have started to measure, and that has changed everything. A question you cannot even begin to answer becomes a question you can attack from one end, filling in the near terms while the far ones stay open. That is progress you can hold. You cannot fill in every blank with confidence. Nobody can, yet. But you can fill in the first ones now, and that is new. When the equation was first written down, we did not even know if other stars had planets at all. We genuinely did not know. It was possible, for all anyone could prove, that our sun was a freak, the one star lucky enough to have worlds around it. We do now. We have found thousands. An exoplanet, a planet orbiting another star, used to be a guess. Now it is a catalog that grows every month, and the tally keeps climbing. It turns out planets are not rare. They are the default. Most stars have them, often several, whole systems of them. That single fact, freshly earned from real observation, pushes the early terms of the equation way up. One of the great unknowns became a known within a single human lifetime. And how did we find them without ever seeing them directly? By reasoning from tiny signs. A planet crossing in front of its star dims that star just a flicker, a fraction of a percent, and we catch the flicker and time it again until the pattern is undeniable. A planet tugs on its star as it orbits, making the star wobble ever so slightly toward us and away. And we catch that wobble in the color of its light, a faint reddening and bluing that repeats. From flickers and wobbles, an entire catalog of distant worlds. We never saw them. We inferred them step by careful step from the light, the same slow, tired light that is all we ever get. And when the numbers from the flicker and the numbers from the wobble agree, you know you are not fooling yourself. Two independent roads to the same answer. That is how confidence is built. And some of those planets sit in the right place, not too close to their star where water would boil away, not too far, where it would freeze solid. The band in between, where liquid water could sit on a surface, we call the Goldilocks zone. Not too hot, not too cold, just right. And Goldilocks zone worlds are turning out to be common too. So the setting for life, the stage, appears to be everywhere. Countless stars, countless planets, a healthy fraction of them at the right temperature for the chemistry we know. Every place we point our instruments, we find more of them. The stage is not scarce. The stage is nearly universal. And now our newest instruments are going one step further. And this is the part that genuinely thrills me. When a planet crosses in front of its star, a sliver of that starlight passes through the planet's air on its way to us. And different gases leave different fingerprints in that light, dark lines at exact colors where each gas drinks the light away. So by reading the light that filtered through a distant atmosphere, we can begin to ask what that air is made of across trillions of miles from a world we will never visit. That is a biosignature we are hunting for, a chemical fingerprint of life on a distant world, not the life itself. The chemical traces life would leave in the air, gases that should not linger together unless something kept making them. We are only just beginning, and it is desperately hard, and every claim has to survive brutal doubt. But the fact that we can even attempt it would have been science fiction a generation ago. We are reading the air of other worlds. Sit with that. We are actually doing it, which brings us to the great collision of ideas, the one that has kept me up more nights than I would admit. If planets are everywhere, and the right conditions are everywhere, and the universe has had billions of years to work with, then where is everybody? That is the Fermi paradox, and it lands like a punch. The reasoning says the galaxy should be teeming, the sky should be busy. And yet, when we look, we hear nothing. No signals, no clear techno-signature, no sign of technology out there, no beam or broadcast that could only have been made. No unmistakable biosignature either. No chemical fingerprint of life on a distant world we can be sure of. Silence. Think about how strange that is. Everything on the checklist for a crowded galaxy keeps coming back yes. Stars, yes, hundreds of billions. Planets, yes, more than stars. Right conditions, yes, common. Time, yes, billions upon billions of years. Far longer than it took life to appear and get clever here. Life got started on our world almost as soon as it could, which hints it might not be a hard trick. Run all those yeses through the reasoning. And the galaxy should be loud. It should be full of chatter, old and new, near and far. And instead, we strain our instruments at the sky and hear the wind. Nothing that shouts, this was made. Nothing that shouts, we are here. That silence is the loudest fact in the whole field. Every ingredient for a crowded galaxy seems to be present, and the galaxy looks empty. Both things appear true at once. And they cannot both be true without something surprising in the middle. Either life is far rarer than the ingredients suggest, and some step in that chain is a near impossible bottleneck, some fantastically unlikely leap that almost nothing ever makes. Maybe the jump from simple life to complex, maybe the jump to intelligence, maybe something earlier we have not even guessed. Or life is common but never lasts long enough to overlap with us, blinking on and off across the ages so that two lit windows are almost never lit at the same time. Or it is out there and we simply have not learned to see it yet, speaking in a way we cannot yet hear. Or too far for the light to have reached us. Every one of those answers is profound, and we do not yet know which one we live inside. We only know that one of them, or something we have not thought of, must be true. Now bring the wanderers back into the frame and feel the two ideas locked together. We have established that objects from other star systems drift through ours all the time. That is settled by reasoning. So here is the question that makes the hair stand up. If natural debris crosses between the stars constantly, then interstellar distance is not the impossible barrier it once seemed. Things do make the crossing. And if a dumb rock can drift from one star to another, then the deep silence becomes harder to explain, not easier. The door between the stars is open. Things come through it. And still, so far, everything that has come through has been stone and ice. Feel the pressure that puts on the puzzle. It would be one thing if the stars were truly sealed off. Each system, a fortress, no object could ever leave. Then the silence would explain itself. Nothing gets across, so of course we hear nothing, but that is not the universe we live in. Ours is a universe where crossings happen, where the gaps get bridged, where pieces of distant worlds show up in our own backyard. The barrier is not absolute, and a barrier that is not absolute makes the silence louder, not softer. If crumbs can drift between the houses, the emptiness of the street becomes a real question and not a given. That is the third pattern, and it is the biggest. The stage is set for a crowded cosmos. The doors between the stars are demonstrably open, and the house stays quiet. We keep finding the conditions for the story, and we keep not finding the story, which means the answer, whatever it is going to be strange. There is no ordinary way out of this. And that, to me, is the most thrilling sentence in all of science. The most likely answers are all extraordinary. Whatever is true here, it will not be dull. So let me pull the three threads together, because they have been reaching for the same place the whole time. Reason it out, and you cannot avoid it. Every star sheds debris. So the space between stars is full of drifting rubble, and that rubble threads through our neighborhood constantly. The walls we imagined were never there. The second thread said that when these visitors arrive, they do not always behave. At least one moved in a way the simplest gravity story could not fully cover, leaving a small, honest puzzle we know exactly how to describe, but not yet how to close. And the third thread said the whole galaxy should be alive with the ingredients for company. The doors between the stars stand open, and yet the silence holds. Watch where those three point. They point at the same place. They all say the boundary between here and out there is far thinner than the comfortable picture allowed. Thin for rocks, thin for ice, thin in principle for anything that can survive the crossing. The sealed room was a story we told ourselves because we could not see past the walls. Now we can see a little past them, and the walls are full of holes. This is where the cosmic perspective earns its name. Step far enough back, and your intuition, built for a small, warm world of fixed ground and near distances, starts to fail. It was never built for this. It was built for the savannah, for judging the leap of a predator, the reach of a river, the near and the now. On the scale of the galaxy, stars drift like boats on a slow current, brushing past each other, spilling debris between them, and the crossing that feels impossible to us is just a matter of enough time. And time, the universe has in staggering supply. The thing that separates the stars is not really a wall at all. It is distance and duration, the same currency again, and given enough of both, things move. What looks like an ocean too wide to cross is only an ocean if you are in a hurry. The galaxy is never in a hurry. Here is what almost nobody sees standing right in the middle of all this. The most important discovery of the last decade is not any single object. It is the shift in us. For all of human history, we assumed the space between stars was empty and impassable, a void that kept every system alone and untouched. That assumption is now dead. We have watched pieces of other stars pass through our own solar system with our own instruments. The question changed underneath us, and most people never noticed. It is no longer whether things cross between the stars. They do. We have seen it. The question is only what crosses and how often, and whether any of it was ever more than stone. That is a smaller question and a sharper one and an infinitely stranger one. And notice how every step got here by reasoning, not by trust. You did not take anyone's word. We started from a fact about our own debris cloud and let the Copernican principle carry it outward to every star. We took the plain arithmetic of gravity and found the one place a visitor broke it. We took the Drake equation not as an oracle, but as a way of splitting a giant question into honest pieces and let the Fermi silence press against it. Each step was small. Each step was checkable. And the small steps stacked into something that quietly rearranges the sky. That is the whole trick. Nothing here required faith. It required patience and a willingness to follow one plain step after another. That is the method, and it is the thing I most want you to walk away holding. Not a fact, a way of thinking. Show you're working. Prefer the boring explanation until it fails. Assume you are not special, and let that assumption take you to places you can never visit. State exactly where the boundary of your knowledge sits, and treat that boundary as the most honest thing you own. Reason like that, and you do not need to be told what the sky is. You can work it out from your chair, and what you work out is stranger and larger and more open than the sealed room they handed you as a child. So let us bring it home. We started with an impossible sounding claim that something entered our solar system and never left. and that if it happened even once, the sky is not what you were told. We began by being honest about how little we can directly touch. Everything we know comes from light, and light is slow, so every look at the sky is a look into the past, layered ghosts arriving all at once. We found the edge of what can ever be known, made of time and not distance, marked by the oldest light there is, the cosmic microwave background glowing faintly from every direction. And we armed ourselves with one humbling rule that turns out to be a lantern. You are not the center. Assume you are typical, and what is true in your small patch is likely true nearly everywhere. From that single lantern, the first revelation followed on its own. Our solar system is a ragged cloud of leftover debris with a bright sun at its heart, its outer halo held by the faintest of grips. So every star is likely the same, and drifting stars tug that debris loose, seeding the space between them with orphaned rock and ice. Multiply a vast sky by billions of years, and rare becomes routine. Interstellar visitors are not a freak event. They are traffic. We only started seeing them because our eyes got better, not because the sky changed. The sky was always full. We were the thing that was empty of the means to look. Then the second revelation complicated the picture in the best way. Most visitors obey gravity, their whole path predictable from a few measurements, the same reliable math that lands a craft on a distant world within minutes of the promised moment. But one did not quite. It sped up, leaving the sun, a small non-gravitational acceleration that the tidiest stories struggled to cover, because the usual visible cause, venting ice glowing into a tail, was not clearly there. Not proof of anything wild, a loose thread, a precisely described gap between what we saw and what we could fully explain. An invitation, not a scandal, a puzzle with a to-do list attached, and the plain admission that most such objects will probably turn out ordinary once we catch enough of them. And the third revelation lifted the whole thing onto the largest stage there is. The Drake equation let us break the question of company into answerable pieces. And the newest pieces came back loud. Planets are everywhere, found by flickers and wobbles in distant light. Thousands of them cataloged and more each month. Goldilocks zone worlds are common. We are even learning to read the air of far worlds for the faint fingerprints of life. The stage for life is set across the entire galaxy. Yet the galaxy is silent. No clear technosignature, no confirmed biosignature, nothing. The Fermi paradox, sharpened by the fact that the doors between stars are demonstrably open, since dumb rock makes the crossing all the time. All three threads reach the same wall and find it full of holes. The boundary between here and out there is thin. Thin for stone, thin for ice, thin in principle for anything that can endure the journey. The sealed room was never real. It was a comfort we built out of not being able to see. And the moment we could see even a little, the comfort dissolved and left something far better in its place. A live question, an open door, a sky that is genuinely, gloriously not yet finished. Now, let me be honest about what is still open, because pretending otherwise would break every rule that got us here. We do not know what that acceleration truly was. The venting ice explanation is reasonable and probably right, and it may simply be that the venting was too faint or too odd to catch. That would be the answer Occam's razor prefers, and preferring it is the disciplined thing to do. But we cannot yet close the thread with the confidence we would want, and honesty means saying so plainly, we do not know how common the more unusual visitors are, because we have only just begun to catch them, and our sample is tiny. 2 objects, a handful of data points cannot tell you the shape of the whole. You cannot draw the coastline of a continent from 2 grains of sand. We need more, and more are coming as our sky surveys grow sharper and faster and catch the next ones sooner, while they are still close enough to study properly. And the biggest question is the one we cannot answer at all yet. We do not know why the sky is silent. We do not know which term in that long chain is the bottleneck, or whether there is a bottleneck at all, or whether the party is simply happening on a frequency we have not learned to hear, or too far away for the light to have crossed to us yet. Every answer on the table is extraordinary, and we cannot yet rule enough of them out. That is not a failure. That is exactly the boundary, drawn honestly, with the edge marked clearly so you know precisely how far the known reaches and where the dark begins. And standing at a well-drawn boundary, looking out, is the finest thing a curious mind ever gets to do. It is the whole reason to keep going. So here is where I leave you. The next time you step outside at night and look up, I want you to try something. Do not see a ceiling. Do not see a sealed room with a few pretty lights stuck to it. See it for what the reasoning says it is. An open neighborhood, a slow drift of houses spilling their leftovers into the gaps between them. A place where things cross, where visitors arrive from stars whose names we do not know, carrying speed from journeys that began before our species did, before the first human ever looked up and wondered. Some of what crosses is stone and ice. Whether any of it is ever more than that, we do not yet know. And that not knowing is not a hole in the picture. It is the most alive part of it. That is the gift of this whole way of thinking. It does not hand you certainty. It hands you a sharper, honest, better lit uncertainty, and it trusts you to find that more thrilling than any tidy lie. You are not too old for this, and you are not too far from the science to follow it. You just proved you can. Every step of the way here, you did the reasoning yourself. You held the light in one hand and the boundary in the other, and you assumed you were not the center, and you followed the argument wherever it went. That is scientific literacy. And it was never about facts memorized. It was about this, the willingness to follow an argument, to prefer the plain explanation, to say clearly where you stop knowing, and to keep looking up anyway. The universe is knowable, but it is not yet known. And that gap, that beautiful unfinished gap, is not a problem to be hidden. It is the reason any of this is worth your evening. Something entered our solar system, and it never left. And the sky above your head is wider and stranger and more open than you were ever told. What a thing to get to be curious about. What a time to be alive and paying attention. If you have stayed with me all the way to here, thank you. Genuinely, your time is the one thing you can never get more of, and you spent a piece of it thinking about the deep sky with me, and I do not take that lightly. If this was the kind of journey you want more of, consider subscribing, so the next one finds you when it is ready. No rush, no pressure, just an open invitation to keep looking up together. Until then, take care of yourself and keep that quiet, stubborn curiosity burning. It is the best thing you own. Thank you for being here.